Hello everyone. In this session, we will continue to talk about more fundamental concepts in machine learning. In the last session, we talked about supervised learning, right? So we said that supervised learning, we will provide the input and output pairs. So it means that the data set is labeled, right, with both input and output, labeled data set. Let's use a fruit classification or recognition example as to explain it. So the data set, we can see D1, D2 to Dn, each one is a sample. And we can see for the each sample Dn equals to xn, yn. So xn is what? Yeah, the feature input, right? So yn is what? The label, which is the output. Then the xn is the image or features of the fruit, the feature vector, and the yn is a label or output of the fruit, right? So this is a supervised learning. So in supervised learning, we have the training data and the test data set, so we don't repeat it again. So in supervised learning, there are mainly two kinds of interesting problems: classification and regression. So let's talk about classification first. So for classification, we mean that the output data is discrete or categorical data. So for example, we see the fruit recognition, right? So this one, we can classify this fruit to different categories. And the second is facial recognition. I think this is more widely used in the society. So who this person is according to an image, right? The facial recognition. And also, for example, anomaly network flow detection. So in all of them, the output are categorical data. So we call them classification. So let's take a widely used example. We call it the handwritten digits recognition. So we often write, for example, the zip code handwriting, right? Handwritten digits. And the system needs to automatically recognize what we have written and then go to the post system. So we can see it's like this. We first provide a handwritten 7, and then there is a trained machine learning model to do these tasks. Then it will tell us what I have written is a 0, 1, 2 till 9. So these 10 categories. So we can see, although they are numbers, right? Numbers, but they are categorical data. Because we want to know which category does this handwritten 7 belongs to. So that's why it's a classification problem. Okay, so now we can make this problem more mathematically, right? So how we can say, we give data set x1, y1, x2, y2 to xn, yn, right? So what is that? xi, this is a matrix that represents i's handwritten digit, the feature vector, right? We can see the yi is the label of the i's handwritten digit, right? So one vector, one label. So now we will learn a function fx to catch the relation between y and x. So when this function fx is learned, we say it's a machine learning model. Then a new x is input, and input to this machine learning model, and the output is a predicted y value. So because the y here is a categorical variable, so we call it this kind of problem classification. So in contrast to classification, there's another kind of problem, we call it a regression. So in regression, the output is not discrete anymore, this is continuous. So since for this problem, we call them regression problems. So here I provide some examples. For example, financial prediction, traffic accident prediction. So let's say in financial prediction, I probably provide the input as a normalized research and development investment. Then I want to find the relation between this one and the output is a profit. So we can say the output, the profit is a number, is a continuous number, and this is not categorical, right? So this is regression. The other, the traffic accident prediction, I want to see the population of the state and the fatal traffic accidents of that state, right? So the find the number of fatal traffic accidents in that state. This is not categorical as well, right? So this is also regression. So we can see that a regression problem, we can give R&D spend, administration spend, the marketing spend, and the location of a company. So this one we call them what? The input feature, right? The output is how much profit can the company expect to make. So here I can provide some data, and then I will do a regression analysis. Right. So this is a problem of regression. So if we write it more mathematically, we can say what? We give data set x1, y1 to x and yn. So x is the input feature vector, including R&D spend, administration spend, marketing spend, and the location of the ith company, and there are n of such data. So yi is the profit of the ith company. And based on this data set, I want to learn a function, right, to predict y using a given x. So then I can do a model and prediction. Because this y is continuous, so this is a regression problem. So all of the above we have talked about, we talk about the supervised learning, right? So now if it's not supervised but semi-supervised, then how to do? So we can see the supervised learning as we have introduced. The model is trained with a data set that some of them, only a few of them, we have labels. While others, there's no labels. So a few labeled data, a lot of unlabeled data. Then how can the algorithm work? So the first step, we can use the labeled data, right, to train a model. Then we have a machine learning model. Then we use this model to predict the unlabeled data. So in this way, we can get what? We call it predicted pseudo-labeled data. Because there is label, but this label is predicted, not the real ones. Then combined with this one and the label data, now we become a supervised learning model, right? Then we can retrain the model to get a machine learning model. So this is a bit introduction of the semi-supervised learning. In unsupervised learning, all that we will provide are unlabeled data. So there's no labels, it means there's no instructions. So the unsupervised learning algorithm is to model the underlying, the structure or distribution of the data without guidelines. In this course, we mainly focus on the supervised learning. So for unsupervised or the semi-supervised learning, we only provide the very basic knowledge. So we can see here is an example of unsupervised learning. We want to segment an image based on different colors. So this is the image. They're all unlabeled data. So then we use unsupervised learning. Here we use a k-means method. Then we segment the image to 3 segmentations according to their colors, right? So we can, if you are interested, you can see this example via MATLAB help file. You can search the color-based image segmentation k-means. This is as a built-in example in MATLAB. So that's all for this session. Thank you very much. Bye-bye.